Hello, once again to everyone. I'd like to welcome you to the Collaborate session, and I do hope you are doing well. Um, I think I'm going to get started. I think we've got everyone now. I know connecting sometimes connection problems tend to make it a process of about a minute or two, but I think we have everyone now. And to get started, for this week's session, we will be looking at section 5.4 only. And yes, and I have started the recording, so you can find it in the usual place if need be. And in this week's section, we'll be looking at annuities. So what we've done before will definitely be applicable to what we're doing now. So we looked at present values, and we started off by looking at a future value of an amount, which was the compound amount. But now we're looking specifically at annuities. Okay, it's a very interesting concept, and it will lead us into the next section, which is 5.5. So please don't look at it in isolation, because in this section, we're going to be looking at present values and future values. And in the next section, we're going to be applying this concept of annuities to repayment of loans and amortization and so on. So we do have four types of annuities. In this section, we're going to be looking at the present value and the future value of both an ordinary annuity and an annuity due. So that makes four of them. Okay, so that's a present value of an ordinary annuity, a future value of an ordinary annuity, present value of an annuity due, and future value of an annuity due. Okay, so I've selected the following problems to give us sort of a good feel of what to expect or what to master in terms of key concepts in this section. And you will notice that it all boils down to, after you've understood, being able to select the correct formula and then apply it properly. Okay, so let us have a look at the first problem. So the first problem is problem number 6, and we are simply asked to find the present value of the given ordinary annuity. Okay, so sometimes it is explicitly mentioned that the annuity is ordinary or it is an annuity due. Sometimes the wording is such that you will be able to figure it out on your own. And for example, if you are told that certain payments are made at the end, then you know that this is an ordinary annuity. If it's just told to you that certain payments are made and we don't specify, then we tend to assume an ordinary annuity. And if payments are made at the beginning, then that would be an annuity due. Okay, so let's have a look at the first one, the ordinary one. Okay. We're given $1,000 every month for 3 years at the monthly rate of 1% compounded monthly. So to relate it to the previous sections, we would be given 1,000, and then we want to find, it would be given $1,000 once, right? But in this case, it is done in a periodic way. It's done every month, and that amount amounts to a certain value. Okay, so in this case, the formula that we use is A equal to R multiplied by 1 minus 1 plus the interest rate to the power of negative number of periods, so that would be n times m divided by the interest rate, and that's divided by m. Okay, because we're doing it monthly. Okay, so we're compounding on a monthly basis, therefore that is why we need to have that m there. Okay, so if we identify the correct formula, the rest is simple algebra. Okay, you need to know that your payment of $1,000 is the R. Okay, so that is the periodic payment. R is the periodic payment. A is the present value, and we use the correct formula. If you substitute your values That's 3 years on a monthly basis. Therefore, that would be 3 times 12, and we will have an amount of $35,450 dollars and 81 cents. Okay, so this is how much paying 1,000 every month for 3 years at the monthly rate of 1% compounded monthly gives us. So imagine if we didn't have compound interest at all. Okay, so paying 1,000 every month for 3 years uh, at a monthly rate, you wouldn't be able to find out how much this money is worth now. But in this case, we're able to actually find the present value. Okay, so this tells us that if you pay 1,000 every month for 3 years at the rate of 1% compounded monthly, this would be equivalent to paying $35,450 dollars and 81 cents now. Okay, so that's the first problem, and it kind of warms us up into these kinds of problems. The next problem is problem number 10, and instead of looking for the ordinary annuity present value, we're now looking at the annuity due. Okay, so in this case, we have $150 paid at the beginning. So it explicitly says at the beginning. Okay, although the question already told us that's annuity due, but it's good that we tend to associate annuity due with payments at the beginning of a period. Okay, so this is done each month, so we know that we're dealing with a M of 12 for 5 years and an N of 5 at the rate of 7% compounded monthly. Okay, so let's evaluate this R of 150 with these values. So now the formula becomes, so this is an annuity due. The formula becomes R multiplied by 1 plus, and then we have that similar term, but now the periods are now minus NM plus 1. So if you look at the textbook, it explains why an annuity due feels like we have that extra payment. That's why the 1 plus comes in there. There is a nice explanation of why the formula is the way it is. But if you then just label your formulas properly, that this is for an ordinary annuity present value, this is for annuity due future value, then you would be able to apply that. Okay, so we substitute all our values and find that 150 is worth for 7% compounded monthly for a period of 5 years is worth $7,619.49 now, because we are looking at present value. Okay, so now we have looked at an example with a present value of both an ordinary annuity and an annuity due. Okay, so now what we want to do in problem number 12 is to now find the future value. Okay, so like we did with the previous two problems, we're going to start with the future value for the ordinary annuity. Okay, so let me just explain what you. So it's a nice question to ask. How does it even make sense? You don't get less out. Okay, you actually get more, because what this is saying, if I just go back to the problem, so just that people are not confused. So this money seems like it's less out because you're paying 1,000. There's 36 months, right? So you kind of want to think you should get more than 36,000. So what this is actually saying is that this is the present value at what it is worth now. So imagine taking this $35,450 dollars and 81 cents and you invest it now, and then you don't do this periodic payments every month. Okay, you invest it now at the same interest rates. In the future, so calculate what this would give you after 3 years. You see that it would be well over 36,000. Okay, So this is the value now at year number 0. So we want to find out what this is worth now, what this investment is worth now. Okay? So now that's what that says. So maybe as a side exercise, I can do that as well on the calculator. Calculate how much this is worth 3 years from now at a monthly rate of 1%, and see what that actually says, what that actually gives you. Okay? So we were looking at problem number 12. Okay. So problem number 12 is saying find the future value of the given ordinary annuity. So now instead of present value, we're looking to the future. Okay. So we are told that the payments are $600, and these are done every quarter for 4 years at the rate of 8% compounded quarterly. So now what you want to evaluate is a future value. And in terms of future value, this is the formula that you use. Okay. So we have R is equal to, S, which is the future value, is equal to R multiplied by 1 plus the interest rate divided by M to the power of N times M minus 1 divided by the interest rate. Okay, so now if you substitute your values, you will get that this $600 paid every quarter for 4 years actually yields 11,183 and 57 cents. Okay, I see there's a question in the chat room. In this specific case, it says monthly rate instead of just saying rate. Okay, I think you were responding to the previous. Okay, cool. It wasn't a question, right? You were responding to someone. Okay. So problem number 16 is also for a future value, but now it is for annuity due. So we would proceed in the same way. We select the correct formula. We are given that we're looking for, we're given a $500 payment every quarter for 12 and a quarter years at the rate of 5% compounded quarterly. Okay, so what happens now is that the formula, instead of it being just N times M, and this part wasn't there before, so we would modify the formula like this, and we'll substitute our values, and in the end get 33,940. Okay, so at this stage, I want to just make a note of that. I know the textbook uses an abbreviated format of the formula, so you have to catch the formula when they introduce it first and know what the abbreviation means. Sometimes it's confusing, but if you understand it, then that's great. And sometimes you see in my calculations, I will show you with the present value of an annuity due. In my calculations, this exponent is negative N times M plus 1. In the textbook, you will see that the exponent is negative N. Sorry, there's a bracket here. Let me just delete that. Oops. Okay. Negative N minus 1. So you need to use this as the power. But if you simplify this, that would be negative N plus 1. So I have the plus 1 there already. And since we are compounding monthly, the N needs to be multiplied by M. So you see my formula is a simplified version. But if you go through the textbook, don't let it confuse you, seeing that there's a negative and then there's a bracket there and so on. So if you simplify the formula, you will get to the same ones that we are using, okay, or I am using. Okay, so that was the first 4 problems, and these problems actually help us to understand present value and future value of both types of annuities, and the rest is actually an application of what annuities do, and you'll see in the next section that will actually do more applications. But the next problem is problem number 18, and let's have a look at what that says. Okay, so in problem number 18, we have an issue of leasing office space. Now, instead of being told that this is the payment, this is the interest rate, and this is the number of periods, we're given a story, okay? So this story simply says we have a company that wishes to lease a temporary office space for a period of 6 months, okay? And the rental fee is $1,500 a month payable in advance. Now, if we should suppose that the company wants to make a lump sum payment at the beginning of the rental period. So see what the keywords are there. Beginning of the rental period to cover all the rental fees due over the 6-month period. Then they're telling us that money is worth 9% compounded monthly. How much should the payment be? So all that they're saying is that this company is supposed to pay $1,500 a month, right, for 6 months. So we have the payment, we have the number of compounding periods, and we've got the interest rate. We just need to find how much they should pay now. So this is the present value for them to cover this month, this 6-month rental. Okay, so it's just the present value of an annuity due that lasts for 6 payments at an interest rate of 9% compounded monthly. Okay, so now that we have deciphered this problem, we can go and use our formula for an annuity due. And be careful now because say the payment is 1,500. That's simple. The interest rate is 9% when you compound monthly. That's simple. When you come to this part, okay, N is number of years. Okay, remember that always. N is number of years, and M is the number of times you compound a year. Okay, so the number of years for this lease is 6 months. Don't go and write 6 there. Write half or 0.5 because 6 months is half of a year. Okay, and then you multiply that by 12 and you actually see that this gives you 6 months. 0.5 times 12 gives you 6 months. Okay, so N is always the number of years. So please be careful always. Okay, so I saw in an assignment when we were looking at, we weren't even looking at annuities, but then we had this issue with some of the problems. Okay, so just be careful with that. If you substitute everything, you find that this company actually should pay 8,834.16. So this now should answer then maybe that previous question you had in terms of why is it less than you should actually have. It just means that if you pay it now and it's compounded with that interest rate, it would then be worth 1,500 a month over 6 months. Okay, so do you see that? That's 8,864 and $34.16 that they should pay now. Okay, if you multiply 1,500 by 6 months, you see they would have paid 9,000 in total. But now if they want to pay a lump sum, it's 8,834. So if they do have this money at their disposal, they can pay it now. Okay. So that's applying all this, all these stories that we're talking about, future value and present value of annuities and annuity due. The next problem would then also be an application question or a word problem. We have equipment purchase. So now what's happening now is a machine is purchased for 3,000 as a down payment and payments of 250 at the end of every 6 months for 6 years. Okay. If interest is at 8% compounded semi-annually, find the corresponding cash price of the machine. Okay, so I hope you understand what cash price means. Okay, it means if you want to buy something by means of periodic payments, the cash price would be how much would you pay now in total for you to not pay these periodic payments. So that would be the cash price. So let me just see the assignments. One year, half a year is easier than these odd numbers. Yeah. Okay, how do you write 7 months? 7 months is 7 out of 12 of a year. Okay, so don't be tempted to round off, because I know 7 divided by 12. Let me just check here. 7 divided by 12. Yeah, so write it in its exact form, 7 divided by 12, instead of writing 0.58, because your accuracy then gets lost. Okay, so if you do round off, if it's money, then it's right at the end when you get to your answer. Don't round off in the intermediate steps, because now if you're dealing with a multi-billion-dollar deal, you're actually rounding off hundreds of thousands of dollars in the process. Okay, so um, let's have a look at this. Yeah, so cash price, I was just explaining what cash price is as the full amount of money you have to pay now. So this is actually just us looking for the present value. Okay, how much is it worth now if you don't want to pay these periodic payments? But in this case, there's also a $3,000 down payment. Okay, so don't let this catch you out. Okay, so this machine is purchased for 3,000 plus 250 annuity. Okay, this is an annuity because it's at the end of every 6 months for 6 years. So if you take this $3,000 and you add it to this annuity, it should tell you, well, the present value of this annuity, because you want to know how much it's worth now, should tell you what the cash price is. Okay, so the down payment plus the present value of the annuity should add up to the cash price. Okay, so 3,000 plus, and you just use, we have an ordinary annuity and it's compounded every 6 months. So M will then be 2, because every 6 months, that means twice a year, and you substitute there and you will figure out that the cash price for this machine is actually 5,346 and 27 cents. Okay, it simply means this annuity of 250 every 6 months for 6 years at that interest rate was worth 2,346 and 27 cents. And if you add that to the 3,000 down payment, you would see how much they should be paying for the machine now. Okay, so that's cash price. That's the amount that we need to pay now. Okay, cool. Is everyone happy with the explanation for or how we went about this problem? Okay, perfect. So that's problem number 20, and the next one is problem number 23, and this is now a nice application of these annuities that we're looking. Okay, so the sinking fund, it's another nice application. So the story in this case, it's quite a bit of words. In 10 years, a $40,000 machine will have a salvage value of 4,000. So this is how much value to have left. Okay, after 10 years. So it will be worth 10% in 10 years. A new machine at that time is expected to sell for $52,000. Okay, so in order to provide funds for the difference between the replacement cost and salvage value, a sinking fund is set up into which equal payments are placed at the end of each year. So you can see Mr. Van Renen there is throwing in the tips that if you see a sinking fund, think future value of annuity. Okay, so the sinking fund here, its purpose is to replace, well, to fund the difference between the replacement cost and the salvage value. So it's raising money to pay for this new machine. If you can get rid of the old one after 10 years for 4,000, then you will have a difference here. Okay, so there's a difference. There's money that you'll still need because you only have 4,000 now and you need to raise the rest to get to 52,000. And you do that by setting up the sinking fund. Okay, you throw money in there, it sinks, and then it grows up until you can use it to replace your machine. So we are told that the interest rate is 7% compounded annually. How much should each payment be? So we are just now saying, okay, if we figure out what the difference between 52,000 and 4,000 is, our future value of however many payments we're putting in for the next 10 years must be equal to that amount at 10% compounded annually. So if you compound annually, you see you actually need to make 10 payments and use the future value formula. Okay, so let's have a look. So the amount needed would then be, and I'm sure you're guessing it already because the difference between these two amounts, 52,000 and 4,000, is $48,000. And we want to figure out what is the periodic payment that you need to make every year, 7% annually, for it to grow to 48. So we use the future value of an annuity, and that's the formula. Notice it's the same as the ones that we're using, it just doesn't have the M because M is equal to 1 since we compound annually. Okay, so if we substitute the values, you'll see that you need to calculate R. Okay, notice that I didn't punch in the values and figure out what this is and rounded it off. I just wrote everything and then I made R the subject of the formula, and then I evaluated that, and finally I rounded off to 2 decimal places at the end. Okay, so you would need every year for 10 years to put $3,474.12 into the sinking fund for it to grow to 48,000, so that when you get your salvage value of 4,000, you can add it to the 48 and you buy a new machine. Okay, so instead of waiting for the old machine to die and then you start thinking, oh, I need to save for a new machine, you can set up a sinking fund. Okay, so I think that is a second last question in this section. And the last one, I think, let's have a look. Okay, so we have a situation where there are two people. So the first one, A, owes B some money, and it's an amount of 10,000, and A agrees to pay B the sum of 1,000 at the end of each year for 10 years, and a final payment at the end of the 11th year. So if you're already wondering why, if he pays 1,000 for 10 years, if it adds up to 10,000, why doesn't he stop there? It's because money has a future value. Okay, so if you owe me 10,000 and you agree to pay me over 10 years, it's not going to be worth 10,000 anymore. That's why we need to consider these interest rates. Okay, so the story goes to say 1,000 at the end of each year for 10 years and a final payment at the end of the 11th year. Okay, so we need to then figure out what the final payment is if interest is at 4% compounded annually. Okay, so think about it this way. In this case, we want the annuity and the final payment added together to be equal to 10,000. Okay, so the money that this person owes, okay, they're going to pay a periodic payment of R. Okay, and we know what the payment is. They say 1,000 every what's at the end of each year, 1,000 at the end of every year. So that's why this formula for R doesn't have the M, because M is equal to 1. Plus, if you assume that the final payment is X, well, if we let it be equal to X, we must then have the present value of this amount as well. See that final payment at the end of the 11th year, this amount, if you find the present value of it, you will then have 11 years. Okay, so let's have a look. The first N here is 10 years. First N is 10 years. That N for the final payment is 11 years because this annuity is for 10 years. The final payment is at the end of the 11th year. Okay, So that's 10 and that's 11. If we substitute, we'll see that we know what that r is. Therefore, we want to find x. To make it the subject of the formula, just like I did with the previous problem, I did not evaluate all of this and then divide it and then round it off in every step. What I did was I put everything together and then I punched it all in one go, and then I got my value of 2,908 and 19 cents. And that would be our final answer. Okay, so if you would like, perhaps if you don't want to type, like Mr. Fanini is saying as well, if you don't want to type this whole thing, if you want to do step by step, you can calculate this part and then make it equal to A, or store it in A, and then you calculate this part and store it in B. So that would be 10,000 minus A, and then you make that B, and then finally you divide B by 1 plus 0.04 to the power of negative 11. Okay, so if you do go through this and you're thinking, why is there nothing dividing anything in the last step? What I did was, to get x on its own, x is equal to, I divided by this bracket, but if you see this negative exponent, it just became positive. Okay, so that's what dividing is. That's why all that stuff that we were struggling with in the A module, that is why we were doing it, because it makes simplification easy. But if you would like, you can still divide by this whole bracket with the negative exponent, same answer. Okay, and that is our story for tonight. I do hope you're all happy with what we've done. If you're not, it's fine. You're not supposed to, not everything is supposed to click all at the same time, but if it you should at least understand the reasoning behind it, so that when you're working on it on your own, you can be able to try other problems and then use the same kind of reasoning. I know it's a bit of a tricky one, but yeah, like I said, just simplify it by thinking this money now is worth 10,000. So you want to know what this annuity is worth now, plus the final payment is worth now. This stuff for the final payment comes from earlier sections that you've done, the present value. So, and I think that's actually 5.2. We've done that already. But yeah, hopefully we can be able to link the different sections. Okay. And this is the last problem of our section. We are actually done. Yeah, I mean, this stuff you want to invest, right? Yeah, that's good. Yeah, all this stuff makes you see that money is actually really worth a lot in the future. And we sometimes sit on a lot of potential by not investing and thinking about the future. Yeah, Corona has different ideas, but yeah. Okay. I think I'm going to end the session now, but if there are any other questions, perhaps you can just pop them in the chat room. Otherwise, we're going to call it a night. And I do hope all of you are doing all right and are keeping safe. And we'll have a good week ahead. Okay. The pleasure is ours. Okay, great, guys. Cheers to everyone. See you guys in the emails and in the discussion forums. I wish you all the best and enjoy the rest of your evening.